Hi, good morning, good afternoon, all. As a part of this project, I picked up price optimization as a topic to look at the opportunity evaluation, create a crisp PM methodology, bring the solution approaches and validation plan, and machine learning system design, and what is the production potential risk in the terms of the production. So I'll quickly so client is a global business, business CPG business in health and beauty products, who is spread across 15 countries. The revenue director wanted to assess the impact of the price on the sales and the margins during the Christmas period. Currently, the business is looking at the same period last year and also getting the inputs from the market or through a gut-based, field-based approach to arrive at the right price of product. The key business questions addressed based on the discussion and the clients on was they wanted to was what would be the what would be the impact of the revenue and the sales volume and the sales volume and with respect to the change in the price of a product and the competitor products. The What would be the optimal price that should be kept that would help business increase the revenue by X percentage during Christmas period. And they are into the Azure cloud at the moment. The business value through is determined through what are the KPIs that are being impacted. They are looking at the sales and margins impact and what is the market share impact once we implement the solution for them. The outcome would be in terms of the X percentage increase in the sales. Benefit would be in terms of the to determine the right opportunity gain and loss and the market share for the business, so that business can trigger a short-term action plans accordingly. Um, the there are two approaches to look at the solutions. One is a standard approach, and another one is advanced. So from a standard perspective, we'll determine the product level price elasticities, determine the factors that impacts the price or the key drivers that impacts the price sales, and what are the insights on the price sensitivity and the sales share. Then from an advanced level, we look at more from a pricing what-if simulation, wherein we determine the impact of the change in the competitor price on the sales. Then look at the price optimization, determine the price by optimizing it to looking at the other external factors such as the market, competition, the holiday impact, the target price being set, and so on. Then we'll build a ROI simulator through a bottom simulation. So from a solutioning standpoint, we'll look at the approach, the validation aspects in terms of the pilot and the full market, and what are the key deliverables for that. So from an approach standpoint, we'll look at determine the internal and external data sources, the KPIs, to build the right feature sets for building the models. Then we'll do the exploratory data analysis, look at the descriptive statistics, descriptive analysis, bring the key insights from the analysis, look at the correlations for key drivers or the KPIs, and then we'll create a price prediction model to predict the right price of product via regression-based models like multivariate or random forest or ensemble models. Then we'll create optimization models through a UCM, and then we need to determine the right external constraint, which is an investment budget, so that we come up with the right price and the revenue impact from the model. From a validation and full market rollout standpoint, we'll implement this solution for a pilot market, which consists of one category and all products in that category for a particular country, and will collect the data or by looking at, or will ingest the data by looking at 2 years of historical period, and at a granularity level, at a category, product, country, and week level. Upon successful implementation of a pilot for one category, then we'll scale it to the other categories in the country. So we'll evaluate the solutions by determining the products that will help business increase the sales by over X percentage. We'll also evaluate the products that will have a negative impact through cannibalization, or there's no impact on the sales. So the key deliverables would be insights on the price sensitivity, cross price elasticities, and so on. And then we'll also bring from a modeling approach, we'll look at the product segmentation, and we'll build the clustering based algorithms like k-means and so on. We'll use that, and then we'll determine the right price for a product through the regression-based models. We'll build the what-if simulation scenarios to determine the change in the the competitor price, and change in the price of the current or own products to that impacts the sales of our products. Then we'll bring the price, create a dynamic price optimization model so as to recommend the right price to the business. These are a list of certain data sets that are must have and good to have. The master data that we require is the product master, the media channel master, promotion calendar, and customer masters. We'll have a transaction data as a point of sales data, and a competitor sales data from external data sources like Nielsen, IRI, and so on. And certain each one of these data sets, the must have and the good to have data sets are being highlighted. Then we'll look at what is the refresh frequency of these data sets, so that it can be incorporated, used for a production purpose accordingly. From a machine learning system design perspective, we'll consider technology stack. As we mentioned earlier, it's the client is on Azure cloud, but from an data engineering standpoint, we look at the offline learning, since it incorporates the data of a weekly and a monthly level, and that would be implemented for a production. And then from a cloud stack point, so it's since it's Azure, we'll recommend on the Azure side the SQL versus the Databricks. So if a client is on a SQL, then we look at a SQL. Otherwise, Databricks, which is recommended, is for a faster processing. Then from a model building standpoint, from a batch, since it's a batch prediction, then one-time price predictions are being given. So we'll consider the models to be built either on AutoML or Python. So, but AutoML has a high cost of generating the models. RStudio is an open source, but would have certain challenges integrating with Azure. But Python would be an easier stack to look at, which is due to the easy integration with Azure, and the Databricks. Python would be an ideal choice. From a visualization standpoint, between Tableau and Power BI, we'll recommend Power BI, considering its easier integration with the Azure platform. So this is an indicative proposal on the Azure cloud architecture, which will be discussed once we have more in-depth discussion with the client. Since the Azure architecture will source the data of a certain transactions in the master data, we'll then do all the storing of the data in the Spark and Scala, and we'll process the data, build the KPIs, generate the derived variables, and so on in the HDFS by using Spark. and build the models on based on the Smart ML library using Scala, and generate the price prediction and optimization models of JSONs. And finally, then these outputs of the JSONs would be then fed into used as either a price prediction model through an Excel, and or then it can be incorporated with the Power BI finally to look at from a visualization standpoint by the business team. Well, this is more of an indicative slide of a CRISP methodology where look at the approach of end-to-end business problem definitions, understand the data, explore the data, build the models, and then evaluate those models and optimize the models after getting the feedback from a business, and then finally roll out the models and do a support on a business as usual processes. The end-to-end indicative slide over here, but we'll go in a little bit more details on the next slide, wherein we look at for each one of these implementation phases. We'll assess the data sources, the hierarchies of the data, the granularity of the data, and the time hierarchy, and so on. Finally, idea over here is on further discovery phases to look at to define the scope of a project in terms of which categories and products that needs to be picked up, what is the period of a data that is available to us, and then finally by looking at and assessing the data, we'll define the success criteria for a pilot on this, and based on this, then we'll start preparing the data. We'll do a data loading exercise, the validation of the data in terms of the missing data, the outliers, the data quality, typical data quality checks we'll perform. Once that is sufficient to do, then we'll move to the transformation, building the KPIs, driving those, creating the drive variables, then building those drive variables, metrics, and the KPIs that will be fed to be used for exploratory data analysis purpose, and will create the hypothesis and find out certain insights for the business to have a further discussion on those insights, and we'll create a markup solution through wireframes and so on, and create a Power BI, a small markup solution on Power BI. And show those insights on the Power BI, and then move to the modeling stage wherein we'll create all these drive variable. We'll use all these features that are being built, and select the right modeling techniques through regression-based models on the optimization techniques, and then build and fine-tune those models based on those evaluation criteria, metrics like MAPE and so on, and then align those outputs, align those business outcomes with the business, this will be delivered to a Power BI. Then from a rollout standpoint, a full market rollout standpoint, once we've determined the pilot rollout and the business value from that, we then plan the future roadmap in terms of the full market. It's important to list down the key assumptions, dependencies, and the risk of the project in terms of the data, in terms of the platform, so that there's a smooth operations while dealing with the business. From a data aspects, the key thing is that majority of time is taken when we do a multiple different historical data loads. So we need to ensure that we limit that considering the timelines in picture. Then we look at the data quality checks. There should not be any duplications in the hierarchy and the duplicate data and so on. We'll perform a historical data load for a 2-year data. We'll build the scope. It's important to define the scopes for this, and basic data quality checks that needs to be done. Then we'll look at certain constraints like a business investment budgets and so on that should be provided during the discovery stages. Output predictions should be available to on a basis on the historical data, but for a new data sets, we should be implemented during the production phase, not on the pilot rollout, unless and until it has been agreed with the client. From a platform standpoint, and the idea over here is to since the client is on Azure, so we'll have a Power BI integrated with from a visualization standpoint, and ensure there's a data security that should be made available, and all reports to be created as an output in the English. There's an engagement team between the client and the consulting, our project team over here. So when we look at the client who interacts, project sponsor, or should interacts with the different client team members over here in terms of the lead data scientists. And then we have a business domains who interacts with these data scientists and my data analysts, and then we have IT Spox who interacts also with the data scientists and the engineers over here. So we ensure that we have the right roles and responsibilities for these roles over here, so that there's no overlaps and the project runs smoothly. Thank you so much for watching here.